This week, 3 open-source releases tackled different AI bottlenecks. Tencent's AngelSpec for lossless speculative decoding, Moonshot AI's MoonEP for balanced MoE training, and Token Saver, a local MCP extension that reduces document token costs. I will explain what each does and who should care. Short version. Tencent released AngelSpec. It trains drafters for MTP and block parallel speculative decoding. Moonshot open-sourced MoonEP and reports a 2.5 times scaling efficiency improvement for Kimi K3, a 2.8 trillion parameter MoE with a 1 million token context window. Marktechpost released Token Saver, an MCP v1.0 bundle for Claude Desktop that uses local hybrid RAG and reports 92 to 99% token savings. Each project fixes a different layer. AngelSpec speeds inference with lossless speculative decoding and ships 2 drafters, MTP and DFly for code and math. MoonEP reduces MoE communication variance by ensuring each rank receives exactly S times K tokens, using planning and prefetching. Token Saver runs a local hybrid RAG pipeline, so Claude receives only capped passages from local files. AngelSpec implements lossless speculative decoding. A drafter proposes multiple tokens, and the frozen target verifies them in one forward pass. AngelSpec trains 2 drafters, MTP for conversation and DFly for code and math. Key training choices: freeze the target backbone and LM head, and use target model rollout so the drafter sees real inference trajectories. Reportedly, mean acceptance at t equals 0 rose from 52.8% to 66.4%. Mean accepted length increased from 2.58 to 2.99. DFly modifies block diffusion with a hybrid target conditioning backbone and a small predecessor conditioned autoregressive head. On Qwen 38 billion, DFly reaches mean accepted length 5.41. Comparisons: DSpark 5.32, DFlash 4.57, MTP 3.24. On High 3A21B, DFly reaches 4.79 versus DFlash 3.69 and MTP 3.00. MoonEP targets imbalance in mixture of experts training. Skew is measured as max VO equals max sub E of TE over T bar minus 1. MoonEP enforces every rank receives exactly S times K tokens by planning redundant experts and prefetching them. It requires 1 contiguous symmetric memory weight tensor per expert projection. Published benchmark defaults: S equals 8,192, E equals 384, H equals 7,168, K equals 8, H prime equals 2048, and 32 SMs. Moonshot reports 0 copy communication and a 2.5 times scaling efficiency improvement for Kimi K3, a 2.8 trillion parameter MoE with a 1 million token context window. Token Saver is a local MCP extension packaged as a single .mcpb bundle under the MIT license. It runs a local MCP server that indexes files and runs a hybrid RAG pipeline, dense plus keyword retrieval, capped passage returns, and only those passages are sent to Claude. The authors used K100 base for token counting and report 92 to 99% token savings compared with sending entire documents. They note Claude's default PDF extraction can produce about 1,500 to 3,000 tokens per page, and that Token Saver supports all 3 Claude 3.5 tiers with fallbacks if embeddings fail. These projects reflect 3 industry pressures: inference cost optimization. AngelSpec accelerates serving without altering frozen target models. Training scale efficiency. MoonEP addresses MoE communication and memory fragmentation under skew. Operational cost and privacy. Token Saver reduces repeated context billing and keeps files local. Which project matters depends on whether you run dense servers, MoE clusters, or desktop RAG workflows. For engineers, AngelSpec is Torch native, builds on TorchSpec, and integrates with VLLM and RDMA hidden state streaming. MoonEP requires contiguous symmetric memory expert tensors and a planner with a prefetch parameter B. Training guidance is B equals E over R, inference guidance B equals 3 to 4. Token Saver ships as a single bundle to avoid Python environment setup. Opportunities are clear. AngelSpec can cut serving costs where workloads have predictable spans like code and math. MoonEP can reduce MoE iteration time by removing communication skew. Token Saver offers operational savings and local document QA for legal, finance, and research teams. Limitations exist. AngelSpec's gains depend on workload entropy and require rollout-trained drafters. DFly used added code and math prompts and removed overlaps with evaluation. MoonEP requires contiguous expert weight layouts and tuning of the prefetch parameter B. Token Saver's savings depend on retrieval quality and indexing. Authors used CL100K-base as a proxy and node embedding fallbacks. The projects do not claim turnkey production installs. Bottom line, the releases are complementary. AngelSpec trains drafters with target model rollout to raise acceptance and throughput on structured workloads. MoonEP provides an engineering contract for balanced expert communication and can reduce MoE training variance at scale. Token Saver is a pragmatic local RAG solution to avoid repeated context costs for document Q&A. Check the repositories for examples before prototyping. Sources are in the description. Key links: AngelSpec, Token Saver, the prompt versus loop versus graph explainer, and MoonEP. Check the original repositories and documentation for implementation details.